In the previous lecture, we reviewed variables, data types, and control statements just to make sure we're comfortable with them, and also to continue working in Qt Creator, which if you haven't used Qt before, you've probably never used. In this lecture, we will learn about slightly more complex and interesting topics, functions and classes. As this course is intended more for intermediate and advanced developers, we won't spend a ton of time on these topics, but we will have a brief discussion and do some short examples. First, let's jump right in and create a new project in Qt Creator called Function Review. So over here, we'll create the new Qt console application here. I'm going to create a subfolder, Function Review, underneath my working directory here, demo workdir, and I'll also call the project Function Review as well. Keep hitting next, and then we should be good. Looks good to me. Of course, we need to write some code, and we'll discuss it a bit as we go along. So I'm going to take out this right here. We don't really need it. I'm going to change that to a 0. We don't need that. We do need Q text stream. All right. And before main, we'll have int square. These are the function prototypes. Void change value. Current num, and then int new num. Notice the ampersand, that wasn't an accident. Void print message. And some notes about this. So we want to know a little bit about functions and how we might categorize them or classify them. So we could classify functions by their return value, and that would fall into two general categories. So we'd have value returning functions and void functions. So in this case, I've got two void functions and one value returning function, specifically an integer returning function. The other way to classify functions is by their parameters. So we could have parameterized, meaning they have parameters, and parameterless, meaning there's no parameters. So in this case, the top one would be a value returning parameterized function. This one, change value, would be a void parameterized function. And then we have the void parameterless function, print message. Let's zoom in a little bit. And I'll give each of these a body, and we'll fill in some of the code there. And then we'll swing back around and fill in main. It's considered a good programming practice or convention to have main as the first defined function in the entire file. So these are function definitions down here, and up here we have the prototypes to give main a heads up and tell it that these are available, but we won't define them there. Some people do put the full definition up here and don't do prototypes, but I don't consider that a really good idea, and I tend to follow the main first ideology. So let's go into the square function here. We'll do n times n, pretty simple, just returns the integer times itself. This one here, change value, this is the pass by value versus pass by reference situation. So this one up here is pass by value. The square has an integer passed by value, and pass by value means it's basically passed by copy. It just makes a copy of whatever argument you pass in. The arguments will fill in the parameters, and in this case, n will take on whatever value is passed in, and then it will return that value times itself. With change value, however, this right here, the current num, is passed by reference. So that means it's not just making a copy of the value, it's actually allowing us to access the address of current num and change its value. So whatever variable is passed in here, it will actually maintain the value. It'll change whatever changes are made in change value will have an effect on this one. Whereas if we change something on int n up here, or new num right here, it's not going to have a lasting impact. So current num equals new num. and then of course print message. So we will have Q text stream cout based on standard out, and then eventually we'll want to flush that. And the only thing we're going to do is we're just going to print out a hello there folks and do an endl there. Pretty cool. So let's run it and test this out. Well, first of all, I'm going to actually change the project setting here under run to make sure that it runs in the terminal first. Then we'll go back here. So now we have to call our functions from main. So Q text stream cout standard out. Eventually we'll want to flush the cout. We'll make a result integer value to change equals 100. And let's do this. So we'll say value to change is currently and we're going to call change value on it. We're going to pass it the value to change and 250. Then we'll pass, or we'll print rather, value to change is now. There we go. And now I'm going to set result equal to square of 5 to test our square function there. Make sure that works. Result equals result cute endl. And we could, of course, call our print message if we'd like, just at the bottom. And let's run it to make sure it works. So we go to build. Could just build this project, but I usually just hit the top one. Go to build, run. And there we go. Value to change is currently 100. We see that it is updated to 250. Results 25. And then our print message function, all it does is just completes a task. In this case, just printing out hello there, folks. So that's pretty awesome. Now that we have our feet wet with some basic usage of functions, let's close this project and create a new one. So we're going to go to File, Close Project. And in this case, we're going to work with user-defined classes. So let's create a new project called Class Review. So new file or project, console application, and I'm going to again make sure I'm up here and call this Class Review. Make sure I'm selecting that folder, and I'll name the project Class Review as well. Keep going, select the kit if you need to, and hit finish. So again, we'll set this to 0 right here, delete the arguments because we don't need them, and we don't need that because it's not doing a bunch of Qt related stuff. So we already have our main.cpp file in here, but we're going to need a couple additional files as well. So before we move on to this, I guess we're probably going to end up printing some stuff. So I'll just do qtextstream. And for sources, I'm actually going to right click here and go to add new. And we could just say C++ class if we wanted to, or we could create them separately. It doesn't really matter. We can make a header file and a source file separately, or create this C++ class. Let's see what that does. So in this case, I'm just going to call it rectangle, and it will create these header files down here, but it makes them lowercase, and I don't particularly like that, so I'm going to capitalize them. Then I'm going to hit next and hit finish, and give it a second, and you will notice that we now have header, and which is rectangle.h, and we also have rectangle.cpp generated. Pretty cool. So we need to fill in, obviously, the rectangle.h and the rectangle.cpp afterwards. So for rectangle.h, you'll notice, if it hadn't done this, I would have added them. These right here are called include guards, if you're not familiar with them. It basically, long story short, if you're not familiar, it basically means that we want to prevent multiple inclusion of the same header files multiple times. So if rectangle was included by another .h file called geometry.h or something like that, and then main included rectangle and also geometry.h, there might be a conflict there because one of them includes it and then the other includes it. This ensures that only one is included where it's needed at any given part. So inside of the rectangle class, we're going to do this. I don't particularly like the way Qt does some of the indenting sometimes. I'm sure there's a bunch of settings I could mess with, but I'm not really worried about that. So we have double length, double width, and we're going to make a 1x1 square, or the unit square with the no argument constructor here. And we'll come back to that in just a minute. So double get width, and we'll talk about all this in just a second. Double get length, like why are we putting const at the end, for example. Set width, set length, and then finally we have an area function which will perform a calculation. So at the very top we have the no arg constructor. So that's the no arg constructor. CTOR is short for constructor if you ever see it like that in code or in comments usually. But a lot of people call it the default constructor, and technically that's actually not right. The default constructor is a no arg constructor, meaning it doesn't have arguments. However, the default constructor is provided by the compiler if you don't provide any constructors. So if I deleted both of these constructors right here, the compiler would provide one because your class needs a constructor in order to create instances. So the no arg constructors means just a constructor with no arguments. The default constructor is actually the no arg constructor that the compiler provides. So there is a distinction. So const at the end of these functions indicates that the function is agreeing not to modify internal data. So like the members, the private data that we'll create. Now the setters, you'll notice, as opposed to the getters, the setters do not have const at the end because their entire purpose in life is to modify the internal data that we're going to have. So what's this internal data? Well, we'll put it down here in a private section. And again, I don't love the way it does the indenting, so I'm going to indent that more. And to represent a rectangle, we need the length and the width. Now we could put area as a data member, but the problem with that is that we could end up with what we call stale data. So as anytime you update the length or the width, you'd also have to update the area, and it's just as easy to calculate it as we need it. So the area function will not need to modify any of the internal data. It's just using the internal data to come up with a calculation, so it has const at the end as well. So also, we want to know some terminology here. So the getters are sometimes just called accessors or observers, and then the setters are usually called mutators. So if you hear that a particular class is immutable, that means that it lacks mutators. It doesn't have any mutators. And if it's mutable, that means that you can modify it. So it usually has some way of mutating, and that usually comes in the form of mutators. So there we go. Now, over to rectangle.cpp, I believe. We are going to, it already included the .h file, so we're going to make some modifications here. So the rectangle, we're going to fill in for the next constructor, the other one that we need to work with. And now we have a couple options here. So you might think, well, wait a minute, why did you name the parameters the exact same as the fields, the private data? And I have to use this in front of this because I can't just say width equals width. It's going to think we're assigning, it'll actually tell you assign variable to itself. It thinks we're assigning the parameter to itself because these parameters, since they have the same name as the fields or the data members of this class, it's going to shadow the data members or the fields. So it makes it so you can't see them. So we have to put this in front of it in order to see them. So this is to overcome name shadowing. Now you might think, why don't I just come up with a different name? Then we won't have name shadowing. Well, a lot of people do that. I've even seen people do width 1 and length 1 and things like that. That's kind of ugly, and there's no reason for that number on the end. It's kind of silly. If you created it and made it double W and double L, the L kind of looks like an I or a 1, and that can get confusing. Or what about wid and len? Well, that might be the best of the options apart from doing this, but when we talk about making variable names, we like to come up with good variable names that make sense and that describe what they're doing. Wid and len do not. So I stick with this convention. I overcome name shadowing using this. We already went to the work of coming up with good names for the private data members, so let's make the parameters the same name and just use the this keyword. Now, what am I going to do with this constructor up here? The noarg constructor. We're going to do this. 1.0, 1.0. Now I could, inside of the noarg constructor, provide some code in here to set width equal to 1 and length equal to 1 directly. I could do that. That would be fine. But we already have another constructor that accomplishes that for us. So we're going to use the delegation syntax or constructor delegation syntax to say, hey, I know you're calling this version of the constructor, but I'm going to delegate it to here. And then so that calls this version of the constructor, passes 1 and 1 there, and that takes care of that. So there will be no default constructor because we've provided constructors. Now, if I deleted this one, there would still not be any default constructor, because if you have any constructors, not just a noarg constructor, if you have any constructors, the compiler does not provide one. It only provides one if there are no constructors available. All right, moving on. We're going to make the getters and setters. So double rectangle. This would be the get width const. Already filled it in for us. That's nice. Now in this case, I don't need to use the this keyword. I could, it's an option, but I don't need to say return this width because there's no conflict. There's no parameter to conflict with. Now the next one is rectangle get length. And then in this one, I just return, of course, the length. And then finally, we have the, or not finally, I guess, but next we have the set width, which has the double width. This one, since there's a name shadowing issue, we do have to use the this keyword. Let me create some space here. And then right here, we're going to create void rectangle set length. And then this guy's length equals the parameter length. So that value is copied here. And then finally we have the area function, the area method. So that one's going to, I have to put const at the end. The area is going to calculate something based on current data that we have. So we do length times width. And of course we need to test this out in main. So we've got this file done. This is good. We've got the .h file done. Now in main, in order to make this work, I need to include rectangle.h. Otherwise I can't access the rectangle. I'm going to create a queue text stream, which we'll call cout, and then make sure that cout is flushed at the end. And then rectangle r1, and then R2 will actually call 5.0, 2.0. So this one on top, since we did not provide any parameters, this will call the noarg constructor, the no argument constructor. The second one will call the one directly that has arguments, right? So let's do this. We could mess around a little further and make more, but I think the area is going to be a proof of concept as to whether this is working or not. Okay, R2 area. Good. And cout dot. Oh, flush, we already did that. That's right. Getting a little carried away. So of course, let's run that real quick here. Good. And now let's run that, and we've got, oh, it ran down here. I'm going to actually change the setting so it runs in the terminal, and then back to here, we'll run it again. And there you go. There's the terminal. So areas 1, areas 10. So that's pretty cool. So we can see that we can easily create instances of rectangles, rectangle objects, and we're able to obtain information out of them like their area. So what if we want a collection of rectangle objects that we create dynamically, meaning at runtime? So what we're going to do is we can comment out what we've done here as far as this stuff's concerned. And I'm going to use a nice data structure that is provided for us. It's very similar to the STL vector. It's just called Q vector. So we're going to have a Q vector that we create at the top, Q vector, and it's going to be of rectangle pointers. We'll call it rectangles. Okay. Now, what we're going to do now is we're going to add a couple of these rectangles here. I guess I can go under the comment or above. It doesn't really matter. We're going to do rectangles dot push back. And what we're going to push back is going to be a new rectangle. So the first time. And then the next one, rectangles dot push back. We're going to do new rectangle 7.5 and 10.5. And we'll do a third one. Rectangles.push back. New rectangle, oops, needs to be capitalized. This one is 20.0 and 15.0. And let's run this. And actually, well, you know what? Let's print out the information about the rectangles first, and then we'll run it. So let's do that. So we'll say list of rectangles. I'm so excited I keep getting ahead of myself. Okay, rectangle pointer R in rectangles. This is the shortcut syntax for for loops. If you're not familiar with it, range-based for loops. So I'm saying for every pointer inside of this container over here, I'm going to access each of those. So R, and we're going to put area, and then we're going to have cute and del. And now we want to dynamically, or return the dynamically allocated memory, right? So we have to do that. Let's add a little space here. Now we're going to do another for loop. This one I'm going to use a standard for loop just to show you. Rectangles.size, and then I++, and then we delete rectangles at I. And then finally I'm just going to put program has finished, because we've done a lot and I just want to make sure that we know when this has ended. So let's run this and see what happens. So build, and oh, seems like there's an error. Let's see what happened here. Oh, rectangles. There we go. Sorry, rectangles. Build it. And seems okay to me. We're going to build run. And there we go. List of rectangles 1, 78.5, and 300. Those are the different areas. That's pretty much what we expect. That's pretty cool. So before moving on, though, I have a little challenge for you. I'd like you to make a small adjustment to the program, just for some practice and review of the material that I hope you're familiar with already. I'd like you to write a function named delete rectangles to take care of deleting the rectangle objects in the Q vector, or rather the objects pointed to by the pointers in the Q vector. The function should have the Q vector set to be passed by reference. Other than that, just write the function with its prototype and call it from main. We're basically already returning the allocated memory, so you have that code there. You're just going to kind of move it out and do it correctly from your function. So pause the video, give this one your best shot. Come back when you're done, or if you need some help. How'd that work out for you? Let's work on it together. So at the top, I'm going to, before main, create my prototype. It's going to be Q vector, rectangle star in the brackets, angle brackets. We'll call this rectangles also. We don't need to do that, but we will. And what I'm going to do is I'm going to actually put the definition down here, and I'm going to delete, or move, I guess. I'm going to cut and paste the code there, which is pretty much exactly what we want. It's the same code, and since we use the same name, we can use it like this. And then I'm going to call the function here, delete rectangles, and pass it the rectangles vector argument. And of course, let's run it again to make sure we didn't break something. Don't want to break anything. That's called a regression. So if you ever hear the term regression testing, we're testing to make sure we didn't break anything. It's a fancy term. All right, so list of rectangles gives us the same information. There shouldn't be a difference between the last run. It's just we've offloaded or refactored the code to have this function take care of the deletion of the rectangles. That looks a little cleaner, I'd say. So excellent, that's great work. So we've reviewed quite a lot in this lecture. This lecture has actually been pretty long. Functions, classes, dynamic memory allocation and release. And also we discussed the QVector class and how to use it, very much like the regular STL vector. In the next lecture, we'll discuss file input and output, or file I/O. Even if you're comfortable with C++, I'd recommend not skipping it because we use the Qt text stream to do our file I/O when we're working with Qt. I can't wait. I'll see you over there in just a bit.